1.1. You can find this one on Canvas. Here we have definition, inductive and deductive reasoning. So inductive reasoning is the process of reasoning to a general conclusion through observations of a specific cases, often used by mathematicians and scientists to predict answers. So this one is to predict answers. And here we have example for this one. The example is every quiz has been easy. And based on what we have given on that part, we may say that we may conclude that our test will be easy. So that is inductive reasoning. So our general conclusion is our test is easy based on what was given, that every quiz was easy. Deductive reasoning is a process of reasoning to a specific conclusion from a general statement. Example, all numbers ending 0 or 5 are divisible by 5, and the number 35 ends with a 5, so it must be divisible by 5. So this is the rule that we have in mathematics. All numbers that are ending in 0 or 5, we should be able to divide those numbers by 5, so it's divisible by 5. So 35 divided by 5 is 7. Natural numbers or counting numbers. I may say natural numbers, sometimes I say counting numbers. And what are those numbers? Is starting with 1. So start with 1 up to infinite. That's why here you use 3 dots, because we don't know what is ending point. Now here we have examples use inductive reasoning to predict. Because inductive reasoning was for prediction, and we're going to use that one here. Here in part A, what is given, we have 5 times 8, 6 times 8, 7 times 8, 8 times 8. Based on what I have here, I have to compare all these numbers and see what I can find. In second column, I see that all these numbers are same. We have 8. So I'm going to use that one here in the next line. In the first line, the first column, we have 5, 6, 7, 8. You can see that we added 1. So it's 5 plus 1 is 6. 6 plus 1 is 7. 7 plus 1 is 8. 8 plus 1, here I should have 9. So 9 times 8, our answer is 72. So this one is increasing by 1. Part B, what I have here, this one called Pascal triangle. What we have here in this case, on this part, here we have all these numbers are 1. That is same for what I have on the right side. All these numbers are 1. What we have inside this triangle is, based on this rule, we have to add these 2 numbers. And that is what I have here on this part. So it's 1 plus 1 is 2. Do the same thing for all of these. Now adding 1 plus 2 is 3. 2 plus 1 is 3. Now next row, next one here, we have 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So using this method to find the numbers on the next line, we are going to have 1 here, because I said all these numbers here are 1. Here on this side, again, I have 1. Now we're trying to find these numbers in between. So 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4, 10. 4 plus 1, here is 5. So this is our answer for this part. The next one, use inductive reasoning to predict the next number in the pattern. Here again, we have to predict, but here it's just asking for 1 number. Sometimes it's asking for 2 numbers or 3 numbers. But I have here is -5, -1, 3, 7, 11. I'll try to add some numbers. So sometimes you may have multiplication, division. So we may have different patterns. But in this case, I see that I have -5. If I add 4, so -5 plus 4 is -1. Let's try this one again and see if are we going to have 3 using this method. -1 plus 4 is 3. Okay. We have to try all of these because sometimes 2 are working, but not all of them. 3 plus 4, 7. 7 plus 4, 11. 11 plus 4. Here we have 15. It's just asking for next number, but I'm going to write more. So 15 plus 4, 19 plus 4, and 3 left. Part B, we have 1, -8, 27, -64. I see that I have different signs. The first one is positive sign, and after that we have negative sign, again positive sign and negative sign. This means I should use power, but my power is not even, should be odd. Because if I use even power, I should have positive sign, not negative. So this means I have odd power. So this is 1 cube. This one is -2 cube. So -2 cube is -8 because we have 2 multiplied as -2 by itself 3 times. -2 times -2 times -2. This one is, I have 1, 2, 3, 4. It's like that, but we have different sign. So it's 3 cube is 27. Here we have again 4, but here is negative. So it's -4 cube. Next one is, here is So we have 1, 2, 3, 4, 5. We have to follow this pattern and see if are we going to have positive or negative sign. So the first one was positive and negative, positive, negative. Here I should have positive. So it's positive Q. It's 5Q, positive 5Q. And our answer is 125. Next one is, it's not asking, but I'm going to write it. So it's 1, 2, 3, 4, 5, 6. But here is negative. So negative 6Q. And this one is negative 216. Next one, these numbers are given 1, 1, 2, 3, 5, 8, 13, 21. We have to see if there is any relation between these numbers. The first one is 1, the second one is 1. Here we have 2, we have 3, we have 5. I'm not sure if you can see that one, but I see that if I add these two, 1 plus 1, I'm going to have 2. See, that is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8, 13. 8 plus 13 is 21. 13 plus 21 is 34. That means the next number here on this board is 34. What this one is called is, you may have seen this one before. This is called Fibonacci sequence. What we usually have, we use F, because this one is Fibonacci, that's why we're using F. F1 is for the first number that we have here in this pattern, that is equal to 1. F2 is the second number that is given on top is 1. Usually we have these given. So this is the pattern that we have for this bar. So we have these two, and also we have this rule that we have to follow. Fn plus 1, this is equal to Fn plus Fn minus 1. Now I'm going to use this rule to find the numbers for the segments. So using this one, Fn plus 1 equal to Fn plus Fn minus 1. For the first one here, we have 1, here we have 2. I'm going to start with 2. So it's 2 plus 1. So that is F3. We already have F1 and F2. That's why we have to start with F3. So using n equal to 2, 2 plus 1, we're going to have F3. And this is F2 plus F2 minus 1. meaning I have F2 plus F1. So our F3 is 1 plus 1, and that is equal to 2. You don't need to write all these because finding the answers are this way is a lot faster. So this is exactly same as that one, but I'm just writing using this rule. The next one, so this was F3, now F4 is equal to F3 plus F2. F5 is F4 plus F3. So this is F3 was 2, F2 was 1. So the answer for this one is 3. Now here in this part, F4 is 3, F3 is 2. This is when you don't have any number and was asking to find all the numbers. So you don't need to write this way. F6, the sixth number that we have here, it's given as 8. You already know the answer? So this is 5 plus 3. Okay, I will write this one here. F7 is equal to 13. If in case you have this one exam, you don't need to write all these. I'm just explaining. You only need to write this one. That's it. So the next number is F7 plus F6. And we do have that one is 21. So it's 13 plus 8 is 21. In this case, the next number in the line that was asking to find is F9. Is a 1, 2, 3, 4, 5, 6, 7, 8. So this one is F9. So in that case, you only need to write 21 plus 13 is equal to 34. You can use either one and test. You can write this way, the first one that I tried, by adding all these numbers. It's better to do that way because we want to make sure that this pattern works for all these numbers, because sometimes it doesn't. Or you can, if you're 100% sure that this is Fibonacci sequence, you can use this one, the last part, F9 equal to F8 plus F7, and add the last two numbers to find F9. Okay, example number 3. Here, the graph will show the temperature in New York City. Part A, assuming this trend continues, use the graph to predict. So here again, we have to predict the temperature on the 7th day. So what we have here is based on what is given on this part. This is first day, second, third, fourth, fifth, and sixth, and it's asking to find temperature because what they have on the vertical line, this is degrees in Fahrenheit, and that is temperature. We have to find what we have here for on 7th day. We may have different methods to find the answer because some may say this method works better than the other one, but we have to try to find the best one that it's based on what is given here. So the first day, the temperature is 43. The second day is 53. The third one is 50. Fourth is 57. So here we have, starting with the first one, we have increasing, then decreasing. Here we have increasing again. Here we have increasing, so increasing. I'm not able to use a method that based on that one, because was increasing, the later decreased, but after that is increasing again. I may say we are going to have increasing at this part, but we have to find what number is. So for that, I'm going to use these numbers and see if am I able to find a pattern and see if there is any relation between these numbers. I'm going to use this 43 and 50 and find the difference. So using these two, find the difference. I'm going to subtract 15 minus 43, and that is 7. So the difference is 7. And do the same thing here on this part. 59 minus 50. Here difference is 9. To this point, what I have is difference for the first part, I got 7, and the second one I got 9. I see that I added 2 here. So this is the relation between these two numbers. 7 plus 2 is 9. I'm going to use that one and add 2 to have 11. So for the next part, I'm expecting to have 11 for the differences. Meaning, if I subtract, I should have 11 here. So that is 59. I should have 70 to be able to have this one equal to 11. The next number here is, and this part is 70. And it's increasing. This is not the only method we can use. You may be able to find different patterns, but the answer you are going to have will be very close to 70. Maybe 71, 72, or 69. So I used this pattern and I got 70. Explain how you use the inductive reasoning to determine your answer. How we use these numbers to predict. So we use these steps. Step 1. I'm just writing what I did on that part. So I subtracted the first and third one, and I added 2. To be able to find the next number for differences is 9. Step 2, 50 plus 9. This is 59, which is the 5th number. Step 3, 59 minus 50 plus 2. To find the third differences is 11. Step 4, to find temperature for 7th day is 59 plus 11 is 70. Again, this is not the only pattern that we can follow. Example number 4, pick any number, any natural number. Multiply the number by 4. So here our pattern is given. It's just saying to follow these steps. Add 6 to the product, divide the sum by 2, and subtract 3 from quotient. What was the relationship between the resulting number and your original number? So the first step is asking to pick a number. So for natural number, I'm using n for natural number. I'm going to use, for example, 7. Now I'm going to follow these steps. Starting that point, we have step 1. We have to multiply by 4, so it's 7 times 4, 28. Now after that, we have add 6 to the product. So it's 28 plus 6 is 34. Next one, divide sum by 2. So it's 34 divided by 2 is 17. This one is quotient because we divided. So this is the answer for division, and that is quotient. Step 4. Subtract 3 from quotient. Quotient is 17 minus 3. Our answer is 14. So this was the original number, but this is the final answer. And it's asking to compare these two, 7 and 14, and see what is the relation between these two numbers. Doubled 14. We can write 7 times 2 is 14. Part B, arbitrarily select some different numbers and repeat the process. We want to see if we use different number, are we going to have again that conclusion or not? So these are natural numbers starting with 1. And part A, I had 7. Here in this case, now let's use n equal to 20. This is our original number. I'm going to follow those steps again. Step 1 was multiplying by 4. Step 2, add 6. Step 3, divide by 2. And finally, step 4, subtract 3. So this is what we have, that is 20, and here is 40. Again, it's multiplied by 2. So it doesn't matter what number we choose. Following those steps, you should have same conclusion. I'm going to write our conclusion here. So when the process followed, the result is double. Now part D is asking to prove what we have in part C. So prove our conclusion. So this is what I'm going to have in general. Let n be natural number. Now we have I will use the column that was given. So the first step was multiplied by 4. So 4 times our natural number. And we had to add 6, divide by 2, and finally subtract 3. I'm going to solve this one. So 4n divided by 2 plus 6 divided by 2 minus 3. 4n divided by 2 is 2n. 6 divided by 2 is 3 minus 3. And subtract all these, here we have 2n. So again, for this part, using n first. Now at the end, we have 2 times n. So again, is double. It's double the original number. Question? So example number 5, find a counterexample to show each statement is incorrect. Part A, the product of any two counting numbers will be an even counting number. So counting numbers are natural numbers. We're trying to find something against this one. So counterexample. Let's try these. Okay, first I'm going to write the definition for this part before starting to find the answer. Because here we have even counting numbers. I'm sure all of you know, but I'm going to write it. So even counting numbers or even natural numbers. Starting with 2, because 2 is even. 2 plus 2, 4, 4 plus 2, 6 plus 2. So this is the pattern to find even natural numbers. So that was even. I'm going to write what odd is. Odd counting or natural numbers. For odd, we have to start with 1, 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9. But here again, we have to add 2. It's same pattern, but starting point is different. So we have to multiply the product of any two counting numbers. It's not even or odd. In this case, we have any natural number. I'm using, for example, 1 times 3. That is 3. This one is odd. It's not even. Another one, I have 3 times 5, 15. Here again, this is not even, it's odd. How I know that this is even counting numbers? It's 15, for example. If the answer for this one was yes, you're going to have even number. If not, it's odd. So is 15 divisible by 2? As it's divisible by 3, it's divisible by 5, but it's not by 2. So the answer for this one is no. So meaning that the product of any two counting numbers is not even. And this was our counter example. So we had 1 and 3. I use this one. Okay, I use this one, or this one. So either one works. 1 and 3, 3 and 5, 5, 7, all of these are same. But if we use 1 times 2, you're gonna have 2, and that is even. It's not counterexample. Say if I use 1 times 2 to have 2, this is even. That's why this is not counterexample. You're not able to use this one for this example for the final answer. So an exam, you only need to write one of these. For example, that one. And also this part. Part B, the product of any 2, 3 digits number is a 5-digit number. I'm going to try, for example, 123 and 456, because it's asking to multiply any 2, 3 digits. We have 3 digits. I'm going to multiply these two. See what's the answer. It's 5 digits or it's not. So this is what I have. This is 5-digit number, but it's asking to find counterexample. Since I have 5 digits, this is not counterexample. I have to try other one. So we have to pick larger number. For example, I'm going to use 900 and 800. So multiply these two. And here is our answer, and this one is 6-digit number. It's not 5. Meaning this one is counter example.